Hi guys, I'm here to clear your composite material doubts like what is a ply, what is a matrix, what's a lamina, what is a fiber. Like everything will be cleared after this video. Fine. Yeah. The main parts of the composite is the two things, which is a matrix and the reinforcement. The matrix is a binder material, for example, that is the epoxy resin. Okay. And then a reinforcement, that is a strengthening material, and the example is a carbon fiber. Okay. The matrix will act as a binder. It is in liquid shape. The matrix will generally be in a liquid shape. It's resin, right? Like so, resin will be in liquid, and that will hold the reinforcement together. What is the reinforcement? That is the carbon fibers, which means the reinforcement will provide strength and stiffness to the composite, which is the fiber. It seems like a thread, but is a very strong thread. Okay, the carbon fiber. Both the components are essential for the composite behavior. Either the absence of one thing won't make a complete composite structure. Okay, we'll see the roles of matrix and the reinforcement. The matrix, which I say is a binder material, epoxy resin, surrounds and supports the fibers, and the matrix is responsible for the liquid thing. The liquid thing, resin, is responsible for transferring the load between the fibers actually. Okay, between mostly the fibers will be nearer, but there will be a gap in which the matrix will flow through, and that will transfer the load between the fibers. The reinforcement, the fibers such as like carbon and glass, we can say carbon fiber and glass fiber, carries most of the applied load because the reinforcement is the strongest one. Okay, and the fiber orientation, fiber we will orient at different angles like 0 degree, 45 degree. Okay, and there is no universal 0 degree and 45 degree, so we will be keeping a reference axis along the structure. Okay, and to that reference axis we will make it like 0 degree, 45 degree. That is what this is the matrix, and this is the reinforcement. When you see, let's say it is like this. Let me show this is straight axis, and let's say this is at a 45 degree. So this is what, like, we will be creating a straight reference axis, and accordingly we will be making the 45 degree of that is a fiber orientation. Fine. And let's say what is ply and lamina. Okay, we know what is fiber, we know what is matrix. Fine. Now the fiber is embedded in a matrix will form a ply. Yeah, this one. Here when you zoom it and see it, like these are the lines, right? Like these lines are the fibers. That is the reinforcement. Got it? When we make it as a sheet, it is called as a ply. The sheet, the ply, the lamina, everything is same. That only the term differs, but the what it means, what it term is the same thing. Okay. Ply is usually unidirectional. When you see it is the straight, right? Like the fibers are straight. So then it is called as unidirectional. If if we put it at a cross at like at 0 and 90 degree, then it will be called as a bidirectional. Okay. Again, I'm saying lamina is a theoretical term for a ply, refers to one thin composite layer. Fine. Yes. Laminate. Laminate is a stack of multiple plies. Yes. This is a single ply. This is also called as lamina. Okay. When we stack, when we arrange it at different orientation angle, this can also be same angle, 0 degree, 0 degree, 0 degree. It can be of any angle. Mostly it will be 0, 45 and 90. These three angles will repeat. And when we orient this lamina in multiple angles and make it as a stack, that is called as a laminate. The stack of multiple plies, the stack of multiple lamina is laminate. The plies are bonded using the matrix. Yeah, like we can't simply keep each ply above one above one, right? Like so we will be using the matrix, that is a liquid, that is a binder material, that will create a laminate. Different ply orientations allow multi-directional load carrying, and what to say, by carefully selecting this stacking sequence, this fiber orientation, this ply orientation, engineers will design the laminate that will make us a lightweight, that will make us a strong laminate and suitable for the real engineering structures. Okay, yeah. So this is a final hierarchy, we can say. Uh, fiber plus matrix is ply. Yeah, fiber plus matrix is ply, also called as lamina. Ply, multiple plies are laminate. Yeah, this is what it is. Multiple plies is called as a laminate. And together we will be forming a structure. This laminate is manufactured to form a structure like this. Yeah. Thank you guys.